This video will give you information about molecular geometries, how to predict the molecular geometry of molecules, and how to draw it. There are 5 that we are going to focus on for this class. However, you should know that there are more. For every molecular geometry that we see here, there is a central atom and there are bonding partners. The central atom in linear is this middle one, here in bent, here in trigonal planar, trigonal pyramid, tetrahedral. You can see that in all of these instances, they are the one in the middle with the bonds coming off of it to other atoms. And then surrounding it is the bonding partner, what I will call the bonding partner. Here. This one has 3, 3, and 4. The bonding partners and the central atoms and the lone pairs of electrons that surround either the central atoms or the bonding partners are essential to predicting the molecular geometries. I'm going to go through and fill in this table for you so you can see how the bonding partners and number of lone pairs affect the shape. We're going to start with linear, and I'll choose the example of carbon dioxide. In this example, carbon is our central atom, and it has 2 bonding partners, and it has 0 lone pairs of electrons on the central atom. When you have any combination of atoms that result in 2 bonding partners and 0 lone pairs on the central atom, the shape will be linear. The shape is linear because of electron repulsion. Electrons are highly negative, like the electrons here I have on oxygen. And the electrons that I have in the bonds are highly negative. Repulsive forces increase potential energy, and molecules will move into shapes that lower the potential energy, that will put them in lowest energy state. You saw this on a simulation of covalent bonds where when the positive charges got closer together, it ended up raising the potential energy. So for molecules, they will arrange in such a way that will put it in the lowest energy conformation. For this, 2 bonding partners and 0 lone pairs, that is linear. Next we have bent. I will use water as our bent example. And as you know, it has 2 sets of lone pairs. Bent molecules have 2 bonding partners and could have 1 or 2 lone pairs. In most cases, you will see 2 lone pairs. The reason that this makes a bent shape and not a linear shape is due to the electron repulsion of the lone pairs and the bonding partners. These would be 90 degrees apart, and that would be planar. However, molecules exist in 3 dimensions, so they can take up different space and increase the angle between the atoms. So if you have something with 2 bonding partners and 1 or 2 pairs of lone pairs, that will be bent in shape. The electrons that are coming out of the central atom will push the bonds into different positions. Next we have trigonal planar, and I will use formaldehyde as my example, H2CO. Trigonal planar will always have 3 bonding partners. And it will have 0 lone pairs on the central atom. Generally, you see this when you have a carbon as the central atom that makes a double bond and 2 single bonds. This angle between the atoms is 120 degrees. Which is the furthest away that 3 bonding partners can get from the central atom in any direction. Because there isn't a lone pair group, it's going to take this conformation because it is the largest away from each other. Again, the electrons in the bonds are going to repel each other and be as far away from each other as possible. Lowest energy state. Next we have trigonal pyramid. I'm going to use NH3 as my example for this. When a molecule is trigonal pyramid, it will have 3 bonding partners and 1 set of lone pairs on the central atom. The reason that it forms this shape is because these electrons coming out the top are repelling the electrons that are in the other bonds. And so it's going to push the other bonds in such a way that they're going to be as far away from each other as possible. So 3 bonding partners, One set of lone pairs around the central atom gets you trigonal pyramid. The last one that we are looking at is tetrahedral, and I'll use methane as my example. In this case, you have 4 bonding partners and 0 lone pairs around the central atom. This is the furthest away that all of these atoms can be, and it's 109.5 degrees. The lone pairs in the bonds are repelling each other, so it will take on a conformation that will push them as far away as possible from each other. There is a strategy to drawing molecules. So let's take this example, CH3CH2OH. How do I draw this with proper geometry? The first step with any molecule is always to draw the Lewis dot structure. So I'm going to do that now. After you've drawn the Lewis dot structure, the next step is to look for the backbone of the molecule. That's the longest string of bonds that is made. So this here is the backbone, and I've got 5 atoms in the backbone. Start with my hydrogen. First bond goes up. Second bond goes down, drawing a zigzag. Third bond goes back up. Because oxygen has these 2 sets of lone pairs and 2 bonding partners, this bond is going to be bent. And back down. Then I can fill in the other hydrogens on the 2 carbons. I know that a carbon with 4 bonds has to be tetrahedral, and that 2 of the bonds are in and out of the plane. They're going to go in the opposite direction as the bonds coming off of the carbon currently, because it'll fill the empty space. So they're going to go up, and then the hydrogens on the middle carbon here will go down in the opposite direction of the bonds that are already on carbon. If they went here, that would be very cramped. All facing in the down direction, be impossible. So put them on the opposite side. And there you have it.